Chris Conklin is a Wisconsin native. He's also a UWC chemistry alumni, the alumni of our program. He was a formidable member of the UWC forensics team. Oddly enough, that's where I met Chris, even though we were in the same department. My roommates were in the forensics team, and so was Chris. So I met Chris at a forensics party at my house. Shortly after graduating from UWC with his chemistry degree, Chris started at SigmaAldrich in Milwaukee. He started as a chemist 2 and has made his way up as a chemist 3, working on several different projects there. In 2015, Millipore and SigmaAldrich merged, so he got a bit of a title change with that. But it was still kind of the same company. I suppose Chris can tell us a little bit more about that. But his new title there was a senior production chemist. In 2018, Chris made the jump over to Agilent Technologies as a product specialist for atomic spectroscopy. So when I asked Chris about some fun facts, he shared with me that he's been a home brewer for about 3 years, and I know we have several people in our audience who are interested in brewing. He enjoys backpacking through the mountains, so he must travel for that since our mountains are very hill-like in Wisconsin. And one of his achievements is that he helped to update the ICPOES methodology for metals testing in the 11th edition of the ACS reagent chemicals for specifications and procedures for reagent and standard grade reference materials. And I think you need to be an analytical chemist to really appreciate that accomplishment. So with that, I'm going to turn the speaker abilities over to Chris here. You can share your screen when you are ready.
Okay. Finding the right screen. That's right. I remember I have to scroll. Discovered that last time. Yeah, so screen is up. Hopefully you can see it. This is me being my renegade chemist self here. I figured, you know, grab everyone's attention early on. All right, so that was actually my zombie preparedness scientist view. But, you know, trying to be a chemist, trying to grab people's attention, that's really what I do. So what I'm talking about today is talking about chemistry. That's really where my career has ended up. And actually, surprisingly, it's kind of what I wanted to do for a long time. I've always loved science. I've always loved presenting, public speaking, kind of a weird combination for a lot of people. But for me, it was something that stuck. And being able to talk about chemistry and chemistry related things was always one of the goals that I had for myself. Took a while to get there. But I've kind of landed there now, and it's been going pretty well. So what are we going to talk about today? We'll cover a little bit of who I am. Why are you listening to me the next 45 minutes? What do I do as an Agilent product specialist? And then we'll talk a little bit about how I got here, because I did not start out as a product specialist. There was a lot of growing that happened to get me here. So we'll work through those 3 main ideas. So who am I? You've agreed to listen to me the next 45 minutes, so hopefully it's someone who's interesting. As Deidre mentioned, I graduated from Eau Claire back in 2006 with my degree in chemistry and a minor in scientific communication. So that's kind of laying the groundwork there for being somebody who can go out and talk about science. As I was there, some of the things I did was I was on the ACSSA, so I did a lot of things there with science outreach, going to meetings and things like that. But I also competed on the forensics team. So, and really kind of combining both of my passions into one activity. As mentioned, I am a home brewer and a hiker. So that's kind of some of my homebrew setup right there. Been brewing now for about 3 years. It's a good task, fun product at the end. Haven't had too many big disasters. The worst one I had was one of my taps didn't quite close one day. So I came down to the basement to refill the beer, and there was a gallon or so on the floor. I remember walking down the stairs thinking to myself, smells like beer down here. Well, that's okay. You know, I brew. These things happen. And I'm holding an empty glass, so that's probably what it is, until I saw the dark puddle underneath the refrigerator. So that was a slightly different plan than I planned on for that evening. So the other thing I do, I like to get out and hike. It's been a while since I've actually been out to the mountains, but I just kind of love poking around and exploring. The Northwoods are great, but I kind of grew up in them. So for me, it's an opportunity to see the mountains and see a little bit more of the world. And the part that makes me relevant today is the fact that I am a product specialist at Agilent. I'm a product specialist for our atomic spectroscopy product line, and I cover east of the Mississippi River. So I have a counterpart who then covers the west. We try to stay on our own side of the country. The challenge with that, though, is he does live in Chicago, so I do have to give him, a little bit of passage to go home. But I do try to give him a little bit of advance notice if I'm going out west, like to the mountains or something, so he doesn't feel like I'm encroaching upon his territory and going to poach his customers. Actually, he and I get along really well. I've known him for years. I've known him since before I joined Agilent. So it's neat, but it does require a lot of territory and meeting a lot of people. So what does it mean to be a product specialist? Well, being a product specialist means that I have a bunch of products that I'm responsible for knowing about. I have to know about them from a technical standpoint, and I have to know about how they fit into the labs. In particular, as I mentioned, I am responsible for atomic spectroscopy, in particular, optical atomic spectroscopy. So I cover AA, atomic absorption. I have flame AA as well as graphite furnace. I look at microwave plasma, which is kind of this unique application that Agilent has created. That's a step up from an AA, but not quite as far as an ICPOES. So I also do inductively coupled plasma optical emission spectroscopy. So those are my three main products that I have to deal with, and they all deal with measuring light. What's neat is when I'm talking to people that work with atomic absorption and they're looking to go to OES maybe, they find themselves a little bit intimidated because they think that AA is just, it's as easy as it gets, and that OES is inherently going to be harder to work with. The way technology has come along, I actually find OES easier, but that's also just kind of where my history has been. But what's neat is a lot of the skills and understanding they have from the atomic absorption carry over to the microwave plasma or the ICPOES, because a lot of the sample preparation ends up being the same. And the phenomenon that I'm looking at in all of these applications, it's just two sides of the same coin. So atomic absorption is looking at light going into the analytes, whereas both the microwave plasma and the ICP are looking at light being given off, light that's being emitted. Now, one of the things I always find interesting is this comparison of AES versus OES. Everything used to be ICP-AES, atomic emission spectroscopy. We've kind of broadened that terminology to include all emission, including ionic, and really even looking at the microwave plasma, it's looking at both atomic as well as ionic emission, but this is one of those weird kind of marketing things. We really wanted the microwave to stand out as different from anything else on the market. So we kind of readopted this moniker of AES for its application. So these are my instruments. These are what I know. These are what I have to talk about. And so what do I do with these instruments? Well, I try to help sell them. Is really kind of what my job is. I am a product specialist, meaning I am in sales. I am in pre-sales mostly, but there's a variety of things that I do. Ultimately, though, it comes down to talking to people. I get to talk about these instruments a lot. Some of that is through seminars or now webinars, where I've got an application note that I'm presenting, or a new instrument has come out on the market, and so I'm explaining how that can fit into a workflow, or maybe it's got new capabilities that allow new research to be done or new product testing to happen. So I get to do a lot of that. I also get to do customer calls. These are more one-on-one interactions. At one point, this used to be in person. I got to travel places and visit people. So I was just saying that, talking earlier, that one of the last times I came into Eau Claire, I was visiting Nestle and Hutchison Technology. because they both have our technology. So I was looking at what they were doing. We had some new instruments out and I wanted to talk to them about that. So we got to do a lot of one-on-one calls like that. Now a lot of that has become virtual, but it's an interesting opportunity to see a bunch of different applications, different uses for the instrument, and try to really think on my feet and figure out how those instruments can help the process. There's also demos. So these are not cheap instruments. And a lot of times people want to see them before they actually commit to buying them. So what does that involve? A lot of times that involves running samples, demonstration samples. Sometimes I'm the one that does the samples, but I do have an entire applications team of application scientists that are in the lab on a more regular basis, and they get to be the ones that actually do a lot more of the sample analysis. And then I also do some post-sales work, doing a lot of customer support. You know, once people have bought the instruments, it's not like we just plug it into the wall and say, all right, good luck, have fun with that. We are here to help. We are here to support. Some of those will go to our tech support line. Some of those go to our applications team. But especially during the sales process, I've gotten to know our customers. I've gotten to know who's using the instrument and understand what they're trying to do. So a lot of times they feel more comfortable just sending me a quick email, giving me a quick call to figure out what's going on. And it's weird because it's very cyclical. You know, sometimes I'll go a week or two without a customer support type call. And then this past week, I've had 4 people reach out to me with questions, all kind of around different things. And that's one of the things that really keeps the job interesting, is every day is completely different. There's something new going on. There's some new challenge. There's something to figure out. So the way I kind of look at my role is I'm the product specialist, and I'm interfacing with our account managers, our applications team, and our customers. So our account managers are going to be the ones who are more responsible for making the sales, monitoring the sales process, finding the customers, finding the opportunities, and maintaining that relationship. Our applications team is very focused on how the samples get run. What do we need to do with the instrumentation to run those samples? They help put out application notes, tech notes, things like that. And then our customers are doing everything. Pretty much anytime you want to look at measuring metals, that's where my instruments come into play, which we'll talk about in a little bit here. But within all of this, there's a lot of communication that goes on between each of the different parties. And I often see myself as kind of sitting in the middle of that. Our account managers are very knowledgeable about the instruments, but they aren't necessarily as technically minded as our applications team or necessarily our customers. Our applications team, they're pretty good at working with customers, but they are very technically minded. And sometimes trying to translate between the account manager and the applications team is where I have to be, because I understand the technical side and I understand the sales side. And so I have to figure out what's being asked for by the customers, translate that to the account managers so they understand what to quote for their instrument package. But then I also have to transfer and translate down to the applications team so that the applications team knows what the customer really is looking for and really wants. One of the things that like our applications team get really excited about is a lot of the work we've put into our instrumentation and software to make method development a lot easier. And so they love talking about how much easier method development is. A lot of times with our customers, they're going to do method development once. They're going to create their method, it works for their samples, they create a template, and day in and day out, they will open that template, run their samples, and call it a day. So trying to get the applications team maybe to back off talking about all of the method development, because sometimes that's a little bit intimidating, and talk about here's how we help you on a day-to-day basis. So I spend a lot of time trying to view all of these roles and figure out how they fit together. And a lot of that is talking and listening. So to do these things, there were a couple of tools at my disposal. First of all, lots of travel. I think this is my map from 2019. I was going all over the place. Pretty much each of those red dots there is a different call, different person I was visiting, a different seminar that I was speaking at, and I got to see a lot of really cool things. We started doing our seminars at unique locations. Historically, a lot of these instrument type seminars happened in hotels, in hotel conference rooms. And once you've seen one hotel conference room, you have seen every hotel conference room. And so we said, hey, if people will come to conference rooms, maybe they'll come to zoos. Maybe we can get some more people to join us at the zoo. So we started going to the zoo. We started going to science museums and really finding a lot of cool, unique places to go, which of course makes the job seem incredibly glamorous, you know, jet setting across the country and seeing a lot of airports. I have spent a lot of time in airports. A lot of time in airports. I don't remember which airport this is, but I spent a lot of time there because I'm pretty sure this was one where I had a flight get canceled. They put me up in the finest, I would say Best Western, but I don't think it was even up to the level of Best Western for a couple of hours in between before they brought me back to jump on another airplane. I've also had the distinguished pleasure of spending the night in the Philadelphia airport. That was all kinds of exciting. It gets real quiet, but they don't kick you out. And when the choice is spending the time there or getting 45 minutes at a hotel, it just doesn't always make sense. So I went ahead and stuck it out. Other exciting things, you get the finest fare of food. When we take customers out, sure, we get to eat real nice. But when you're just traveling and trying to get from point A to point B, there's a number of burger and fries involved. That's also at an airport. That's actually at the Philadelphia airport. That's the Smash Burger there. Had a lot of times eating there because it's quick and it's near my airplane terminal that flies me back to Milwaukee. Beyond the finest fares, you can also get flat tires. That one actually happened in Hudson. I was actually hoping to stop in Eau Claire. I was coming back from the Twin Cities, and I wanted to stop in and say hi to some people, but that did not happen because you can see there was a large hole in the tire. I was driving down the road talking to one of my account managers, heard this noise, and like, oh, that's kind of weird. The low pressure signal popped up on my dashboard. I'm like, well, all right, I'll pull over at the next exit and take a look at it. And then the tire really started to grip weird. I'm like, I'm going to have to call you back. I think you have a flat tire. So I pulled it over to the side of the road. Sure enough, there was a hole in it. That was actually the smaller hole in the tire. There was one on the backside that was much larger. So travel can be really cool and really exciting, and sometimes it can just be really exciting. So what do I do now? Well, I used to travel a lot, but not so much these days. This is my 2020 calendar. Haven't really gone a lot of places in the past year here, but I still have to do my job. I still have to do seminars. I still have to do customer calls. I still have to do interactions. So how do I do that? Oh, this is my home desk. This is actually where I am sitting right now. So you change, you adapt, and you just roll with it. As I was mentioning to people just before this, when we were just kind of chatting before, they say the only constant is change, and that really is the truth. Having been in a variety of different roles, different applications, accepting that change and rolling with it is the best way to get forward. So take that for what it's worth. So I have to do a lot to promote products. So what does that look like? Well, these are some of the products that I have in my portfolio. So if we look at Agilent, Agilent as a company is a huge company. We have a lot of different instrumentation. We have a lot of chromatography. So that's what most people think of when they think of Agilent. They think of our GCs. They think of our HPLCs. They think of chromatography. But Agilent has been doing atomic spectroscopy for quite a while now as well. They've been doing a lot of mass spec work, ICP mass spec, for years and years. They actually bolstered their atomic portfolio back in 2012, acquiring a company called Varian. Varian was based out of Melbourne, Australia. And that's actually where my product line comes from. So these are my 3 instruments. They all do similar things, but they have a different way of doing it, and they have different roles in the market. So one of the biggest differences when we start looking across the 3 applications is their sensitivity. So when I talk to customers, one of the biggest questions that I have to ask is, what elements are you looking for, and how low do you need to go? And then how much are you willing to spend? Budget is also something that becomes a critical part of these discussions. But if you're looking at just a couple of elements, a handful of elements down into the part per million range in the periodic table, looking at the metals, the Flame AA is still a great instrument for those applications. You can get results pretty quickly, and it's a fairly robust technique. It's been around since 1957. So we figured out how to make AA work pretty well. If you need a little bit better sensitivity and you're starting to look through a couple more elements, then we might start looking at our microwave plasma. Our microwave plasma is a little bit more sensitive, and we can start to put auto samplers on the front of it. So if you're running a lot of samples and you want to leave things unattended, microwave plasma starts to become a cool technique. Flame AA, we can put an auto sampler on the front, but it is an open acetylene flame, or an acetylene nitrous oxide flame. When you start telling safety teams that you have an open acetylene flame in your lab and that you want to leave it unattended for hours on end, they're not usually excited about that. So while we can put an auto sampler on the front of it, we don't do that all that often. So when people start telling me they need to run more samples, they need more throughput, then we start talking about the microwave plasma. The microwave plasma is actually a really neat little instrument because it generates its plasma based off of nitrogen. And with the nitrogen, you can actually hook up a nitrogen generator to the front end of the instrument to supply all of your nitrogen. Whereas with your Flame AA or your ICPOES, you have to have another gas that's piped in. In the case of AA, like I mentioned, we've got that air acetylene or nitrous oxide. We can't pull that out of the air, which is fortunate because otherwise the atmosphere would probably constantly be on fire. So you have to have high pressure cylinders. Some places that we work with, mining institutes, for example, or mines in general, they aren't located next to a city. So for them to get deliveries of gases can be a challenge. Introduce microwave plasma that uses a nitrogen-based plasma. Nitrogen from that nitrogen generator takes care of all the supply you need. It does have some challenges though. So compared to an ICPOES, the plasma is not as hot, and it's a molecular plasma instead of an atomic plasma. The OES is going to use an argon-based plasma. So you get a little bit lower sensitivity compared to the OES, and you have some unique interferences that we're looking at. It is also still a sequential instrument, meaning you run one element right after the other. Granted, you've just introduced the sample, so your auto sampler is taking care of it, and you don't really have to worry about it too much. But it is still going to be a slightly longer analysis. And then we have the ICPOES, which is really kind of my flagship product. It has better sensitivity than the other two. I can go down to parts per billion, or in some cases, sub-parts per billion detection limits within a solution. I can look at most of the periodic table simultaneously. I can't do a couple of elements. Noble gases are out. Halogens are a little bit tough. And then carbon, nitrogen, oxygen, and hydrogen aren't great either, in large part just because there's so much of them around in the atmosphere that trying to distinguish them from the background at a trace level just isn't feasible. But the OES does become simultaneous, meaning we can look at a bunch of wavelengths at the same time without increasing that runtime. So we have some applications, oil labs that are doing wear metal analysis, or soils labs that are monitoring fields, fertilizers, that they are doing one sample every 10 seconds before we flip on to the next, and they're able to screen everything very quickly. Granted, they're not getting the same level of sensitivity as you can if you take a little bit longer read time, but they do get high level readings, and that's what they're looking for, is they're just trying to monitor trends. So really depending on the application and how many samples they're doing, what levels they're looking at, that really starts to determine which instrument is the right fit for them. And that's a large part of my role, is figuring out which one is the right fit. Because one of the last things I'd want to do is put in an instrument that doesn't meet their needs. Because then I'm going to have to spend a lot of time troubleshooting for them. They're not going to be happy, and they're not going to get moving forward on what they want to do. So it really is important for me to figure out what is the right instrument. As we look at these instruments, one of the things I do spend a lot of time talking about is how they work. So this is just kind of a quick introduction to ICPOES. What's it do? Well, it measures metals in solution. How does it do that? Well, we create a fine aerosol into a spray chamber, and we aspirate that aerosol into the plasma. The element we see in this plasma right now is yttrium. Almost every picture you see of ICP plasma is probably yttrium, because it is one of the most colorful elements to look at, and it shows off the zones of the plasma very well. It's kind of neat looking at the different elements. This is a little bit of an aside that I'll talk about in a little bit more detail, but when I was at SigmaAldrich in the lab, we pretty much got to see the periodic table. We had 1 week where we had a bunch of rare earth foils coming through. So I've worked with cerium, praseodymium, neodymium, that whole bottom chunk of the periodic table that most people pretend doesn't exist. But what's cool about them is they make really neat colors in the plasma. Like if you look at the different colors, some of them are really vibrant, and I like to think they kind of look like lightsaber colors, which you can tell is relevant based on my background of my home office here. So cool colors in plasma, but a lot of times you'll see yttrium because it shows you the analytical zone, which is this blue zone, the recombination zone, which is this magenta color that tails off, and then the heart of the plasma, this ionization bullet down here. It's cool. So anyway, getting back on track here. We aspirate the sample into the plasma, which allows us to excite those electrons. So the plasma acts as our excitation source, and we're able to promote those electrons to their higher energy state. When they come back to their ground state, we finally get some light. That's what I can look at. Although atomic absorption is going to look at the energy that's going in. So that's kind of the first step. But then we can look at the light giving off in our emission spectroscopy. Based off of that light, every wave element has its own unique spectrum. So we can start looking at individual wavelengths and looking at their intensity. That intensity is going to be directly proportional to the concentration. So we take this emission light, run it through our spectrometer, sort out the spectrum, looking at from 167 to 785 nanometers. We can see a lot of different wavelengths. And like I said, every wavelength or every element has its unique spectrum, but not every wavelength is unique to that element. So one of the challenges we face is trying to deal with those spectral interferences. But regardless, what we can do is we can run a known standard or known set of standards through the instrument based on that calibration and compare them to our unknowns, because that light will be directly proportional to the concentration in the sample. So that opens up a wide variety of applications. So there are even parts of the periodic table we could probably do by ICPOES, but you get down to meitnerium, element 109, and there's only been 3 atoms ever made. We could probably see it, but I don't know what we're going to use for calibration. But ICPOES becomes a very versatile technique. Being able to look at all of those elements at a variety of concentrations from subpart per billion all the way up through percentage level quantification allows us to work in a variety of different industries. So we spend a lot of time in the environmental industry. The instrument is used for water testing, soils testing. We test sludges and sediments. There's a lot of specific protocols written around using this technique. We also have a fairly large footprint in petrochem and energy. We test wear metal, so machining groups that are making sure that the metals aren't showing up in their lubricants. This becomes a huge high throughput area. We are working with batteries, lithium ion batteries, testing that lithium, making sure that it's right. Testing crude oil to make sure that it's meeting various grades. We're also in food. We've got testing for milk powder, palm oil, fruit juices. I have a fun talk that I do called Keeping Happy Hour Happy, because we've tested wine, beer, and whiskey using these instruments. So it's really a diverse field that I get to talk to, and every day is somewhat different, which is really neat. Being on the instrument side has really opened my eyes to a lot of the ways that the instrument can be used, because I didn't start out as a product specialist. I didn't start out trying to sell instruments. I started out at SigmaAldrich Chemical. This is where my saga begins. I actually learned about SigmaAldrich through one of these seminars back in 2005. One of our guest speakers was also an Eau Claire alum who went on to work at SigmaAldrich, and they were telling me about the company, or well, not me specifically, but they were talking about the company in general. And I thought to myself, well, that's an option. You know, it sounds like they're a pretty good company. Sounds like they've got a lot of opportunity. They were not my first choice. I know I applied to a bunch of jobs. Some of them I even got interviews to. Most of them I don't remember getting a call back to. But I did get called down to SigmaAldrich. Went and interviewed at their Sheboygan Falls facility for the first time as looking to be a production chemist, which was a little bit out of my comfort zone. I am not a synthetic chemist by any stretch of the imagination. I've always fancied myself more on the analytical side, but if you give me a good recipe, I can follow it, which really shows in the beer that I make. Good at following recipes, keeping a good, clean lab procedure. But I interviewed, and it just so happens that one of the vice presidents happened to be on site. And I was talking with the HR person, like, you know what? You should talk to this guy for a minute. They're like, okay. So I went and talked to the VP and introduced myself and some of the things that I liked. You know, I liked science. I liked analytical chemistry. I liked public speaking. He said, you should interview at our Milwaukee site. There's more opportunities down there. So I went down and I interviewed in QC and I interviewed in marketing. In marketing, I learned a very valuable lesson. Know your audience. I made a joke about, because I assumed I was interviewing at a chemical company. Therefore, everybody's background must be in chemistry. And being a fresh-eyed graduate, I was like, yeah, you know, I had a chemistry degree. You know, they asked some question about challenging opportunities and things like that. Well, you know, I was a chemistry degree, you know, did P-Chem, did all of that, you know, unlike business majors who have a minor in Xbox, at which point they said, oh, I have a business major. And I said, oh, guess I'm not getting this job. All right, I didn't say that last part out loud. I gamely barreled through the interview, but I did not get that job. Fortunately, the QC department, though, they called me back, and they offered me a role as a chemist one. So my LinkedIn is apparently a little bit outdated. I actually started as a chemist one. There I am with my very first ICPOES at SigmaAldrich's Milwaukee QC facility in their trace metals lab. It was a beast of an instrument. You can't see how long it is there, but it is a floor model. It was like 13 years old when I started. By the end, we were replacing fuses down here. They were about the size of cigars. The service engineer took out one of the solenoid valves just to get us to run through another week. It's like, well, if you're going to keep running or try to sell, I wouldn't do this, but you only need another week. We'll just let it keep cooling. Out came the solenoid valve. This sticker never actually stuck to the instrument beyond this. Too many chemicals, I guess. It just didn't want to stick. So this is where I started. My job was preparing samples, running samples, reporting samples. Over and over and over and over and over again, filling up these tiny little test tubes and putting them on the auto sampler to hit go. I did this for several years, but I did start making some process improvements within the lab, such as using the software to do measurements for us. We had one thing where we were determining spike recoveries. We'd add a known amount of sample to our, or known amount of analyte to our sample, make sure we got that difference to tell us that the instrument was reading correctly. And the way we did that when I started was we had a ruler and we held it up to our CRT monitor and kind of hoped that it had enough bend on the front of the screen that we could measure the difference in peak height. I did that for a while, and I was just poking around the software one day and I found this thing that said spike calculations. And I said, huh, does this mean it can do it for me and actually get accurate results? Sure enough, it could. So we started using the software the way we were supposed to be using the software. This led to some opportunities, such as a special project to replace that ICPOES. I think I'd been there about a year and they said, all right, we need a new one. Go find it. Here's your budget. And the number they gave me was a very large number, and I was fairly intimidated because I'd only been doing this for a year. What do I know? I have someone else in the lab who was my trainer and boss, like intermediate boss, who had been doing this for decades. And he was along. I mean, he helped me do the process, but it was still kind of intimidating. So what did I buy? I bought this instrument, the Varian ICPOES. It's about as long as the instrument that I'm standing in front of, but you'll notice it now fits on top of the bench. So it was about half the size, and the old instrument used to sit here, and it took up all of this space under this vent. This was a very important opportunity for me because it allowed me to start talking to instrument vendors. I got to learn a lot about the technique because as part of the sales process, you need to learn more about what the instrument is doing. Whereas in the lab, it is push the button, get the number, get more samples out the door. Not necessarily a lot of time to learn about the instrument. So this was where I first got to meet a lot of the wider world of metals testing. Cool part about that was, hey, I did a good job. So I got a promotion. They moved me up to Chem 2, where my responsibilities were prep samples, run samples, and report samples. But I got to do some more stuff too. I got to start developing methods. I got to start training new lab staff on the instrument, purchased more instruments. I actually replaced every instrument in that lab by the time I left. I was there for about 12 years. So I replaced an ICPOES, a flame AA, a graphite furnace AA, an ICP mass spec, a balance, as well as a microwave digestion system. But I got to start doing more things. Also, as I proved that I could understand what was going on in the instrument, well, when people would come through for tours, I got to talk to them about the instrument and what the lab did, which was a lot of fun. And then I started becoming a resource for other sites within our company, because SigmaAldrich isn't just the Milwaukee facility. There was a facility in St. Louis, Lenexa, Kansas, Sheboygan Falls, Wisconsin, Urbana, Illinois, and a variety of other ones. So once they got word that I actually kind of knew what I was doing, they started asking me questions. And it was actually through that I got to help write that application in the ACS handbook. So that was cool. Got to do more things there. Did that for a couple of more years. And I started becoming an internal auditor for the company. So this was kind of branching out of the chemistry and looking more into the regulatory side of things. Big part of why I did that was I wanted to learn more about the company. It was an opportunity to see different departments and see what they were doing. I've been responding to auditors, but now I got to be one, and I got to see how our production department worked, how our packaging department worked. I really got to see a lot more of how the pieces came together and got to learn more about people in the company. Did that for a while, started making process improvements throughout the department, moving beyond just my lab, but actually starting to focus on how do we implement things like 5S or other productivity features into the department. So I got to move beyond just my little corner of the world and start to see things from a bigger perspective, which was cool because I got another promotion. They figured, hey, you're doing things for the entire department now, really taking on more of a leadership role, and we want to try to keep you around a little bit longer. So I got to start leading department level initiatives, which was really, really neat. And what's cool about this entire process is most of these things didn't exist before I started them. It was seeing a need and doing it. So even though my title was Chemist 1, 2, or 3, and my fundamental technical roles were run samples, get results, report results, I was really able to start growing my role and grabbing things that I found interesting. Like I started a science outreach program for my department. One of my colleagues, their student was doing a science fair. And they said, hey, you want to help with science fair? I said, yes, I absolutely want to help with a science fair. And so to do that, we went in beforehand and did some science demos, get the kids excited for it. Elementary school level, it was great. And I was telling my manager at the time that I was, I needed a day to go do this. I'm like, oh yeah, that's really cool. You should go do that. I have a daughter. You should do that for her school too. And I said, okay, let's do that. And so I started building the science outreach program, which was a ton of fun. And really was kind of getting my bearing in the company, figuring out where things were happening. And then MerckKGa from Darmstadt, Germany bought us, which came as a huge surprise for everyone. And there was a lot of questions at that point. What was going to happen? How is this going to go? It's an acquisition. A lot of people were uncertain. Turns out Merck, based in Germany, is a really good company. They have to call themselves Millipore Sigma in the US and Canada because a long, very interesting story that I don't have time for. But essentially, Merck & Co. owns the rights to Merck in the US, but Merck, based in Germany, is 350-some years old. There were some world wars that happened, different companies split off, things like that, leading to this naming nomenclature. But it turns out they were a really cool company. They'd been around for a while. They did a lot to treat their companies well. I got a weird new title. I call it like senior production scientist or senior production chemist, but it was like actually production scientist senior or something like that. It was weird. But I still got to do a lot of the same stuff. That science program that I'd been doing actually became a corporate level program. They got to help design. I got to still do a little bit of prep, a little bit of samples. But at that point in my career, kind of the last couple of years, I wasn't doing as much with the samples and the instrument. Like if there was a special project I was helping out, but I had a team. The lab was 4 people, and the other people were really great at running samples. And so I could trust them to do that. I could focus more on lab operations as well as department operations and trying to do bigger things. Responding to auditors. So not only was I an auditor representative in my lab, I became the audit point of contact for the entire department, which was great because then I got to talk to people. Because if you remember at the very beginning, I said the 2 things that I liked to do were science and talk to people. Running samples doesn't involve talking to a lot of people. So really kind of growing the career, growing the opportunity, finding these chances to talk to people really helped. And that kind of brings us full circle. This brings me up to the Agilent adventure. How did it happen? Well, like I said, I got to know a lot of people at the Varian and later Agilent when I bought that very first instrument. Stayed in contact with them. One of them was my counterpart in the West, who's the product specialist over there. Then I learned a lot about the techniques and the instruments by spending a lot of time with our service engineers. Every time a service engineer is on site, if you have a chance to talk with them and shadow them, take it. You will learn a ton. From there, I applied to a couple of positions at Agilent. They put me as runner-up each time, which means I was not hired. So I kept working at Aldrich, which was fine. I really liked that lab and was having a good time. And I wasn't actually even looking at jobs at that point. But they started to remember me. And eventually, this product specialist position opened up. And I had an email when I came back from New Year's vacation saying, hey, this position is open. We think you should apply. I took that subtle hint and I applied. And this time I was not the runner-up. I was the actual person who got the job. And, you know, the rest is history. Or more accurately, I am still trying to figure out what I'm doing on a daily basis. But it's cool. I really enjoy the job. It's been a neat position. I get to do the things that I wanted to do. I get to do chemistry. I get to follow up with the analytical side, and I get to talk to people. So everything finally came together. It took a while. I was at Aldrich for 12 years, and now I'm here. I've been here for about 3 years at Agilent. So that's my story. That's a little bit about what I do and why I do it.
All right. Thank you so much. It was a great talk. Clap, clap, everybody. I'm sure everybody's muted. We will start our Q&A. Students up first, of course. Go ahead and unmute yourself.
They're all just absolutely shocked and in awe at the conversation, have to pick their jaws up off their desks, I'm sure.
So I have a question. How was the transition to the business side of things after being, you know, working in the lab for so long? I mean, I know you picked up a lot of those responsibilities along the way and that made your job a lot more social, but how was it the switch once you switched over to Agilent?
It was definitely a bit of a shock to start. At the Millipore Sigma side, being in quality control, everything was very procedural. You had procedures on how to run samples, you had procedures on data entry, you had procedures on maintenance. There were procedures for everything, lots of stats. And then I moved to sales, and there weren't any. And trying to adapt to that and figure out how to do a sale with everyone being different and every account manager doing something a little bit different. I have 11 account managers that I work with, and they all do things differently. That was a huge culture shock and a huge learning point. And actually, one of them who was part of my interview, I was talking with them a couple months ago, and they're like, yeah, when I talked to you during that interview, I figured this was going to be a shock because you are used to a scientific procedure for everything, and now you don't have one. But I just kind of kept on keeping on, tried to develop some procedures where I can, but just learn to roll with it, you know, roll with the change. And what's cool is everyone on the team is part of the team. We all want to succeed. We all succeed together, and so we all work together. And that's been important.
Gotcha.
But it was definitely a shock.
Any other questions?
So you talked about kind of your worst experiences traveling. What would you say your favorite place to be was, or the best?
Oh, there have been a lot of really cool. All right, so the coolest travel experience I got to do. My product line is based in Melbourne, Australia, and they sent me there for a week. So that was really cool. That was the first time I'd really traveled internationally. And since I was there, I took an extra week of vacation because I figured I'm here. Let me explore around Melbourne. But that was just, it was really neat. It was cool to explore the city. It was cool to see the factory where these instruments are designed. So I have very, very fond memories of that. It's also nice to occasionally zip down to Florida in January to escape the bitter cold of Wisconsin. It's less neat though when you come back and it's 30 below with a foot of snow on the ground. That's very jarring.
Probably won't find it as easy to get into Melbourne now.
So, Chris, being a student of our department, as you were going into your first job with Sigma, and even as you transitioned to more of the product specialist role with all of these different analytical techniques, we don't often teach things like what is plasma and how is it used as a detection or a sample preparation tool. So what kind of things would you suggest our students pay attention to, and how do you pivot on the job?
Yeah, so that's true. When I started, I pointed out that I was not an organic chemist, and they said, that's fine. Our metals inorganic lab really needs some help right now, so we're going to put you there to fix it. Here's an ICPOES, and I said, oh, how does that work? What do I do with that? But what really kind of helped do that was learning about instruments, thinking about how they work, thinking about the process, what's happening to the sample, because you're not going to know every piece of analytical instrumentation out there. But if you can work through the process of how do I start with this and get to a result and think through each step logically, that helps tremendously with troubleshooting. Just getting good lab procedure down is also a huge help. Documentation, especially in a lot of industries, they have to be audited. So you have to have really good notes and documentation for what you're doing. A lot of times learning the instrument, the company will be able to train you on that. You can learn how to run the instrument, but having a good basis in understanding how things work and being able to logically work through it, as well as having a good basis in lab skills was what was critical for me. And just starting out, learn, listen to the training, see what's going on. Before you start trying to make a whole bunch of changes, learn why things are the way they are. There might be a reason that you hold samples for a month, even though you've never seen anyone ever go back to use them. There also might not be. So accepting the excuse or justification of, well, that's just the way we've always done it, is also not necessarily the way to go ahead. Find out why things are done the way they're.
Excellent. Excellent. So Erica, I think your hand is residual. Anybody else got a question they want to pose to Chris?
Well, did you visit Carlton and United? Since you are a home brewer.
Mm-hmm.
You took the trip to Carlton then?
I took the trip to where?
Carlton and United Brewing.
I did not. I didn't get to. That was not a place that I found.
Oh, thought as a home brewer you'd have been right on it.
Yeah, well, part of the other thing that happened with like the Melbourne trip was, so I went I think they sent me after I'd been with the company for about 3 months, so I didn't have a lot of time to plan,
Yeah.
and I was still doing a lot of just trying to figure out how do I work my new computer. Oh, and I'm traveling internationally. Okay, that's cool. I'm gonna take a week of vacation while I'm there. I'm sure I'll be able to figure out something while I'm there, and I did. So I went down. I saw the blue penguins one afternoon.
Oh,
Went along the shipwrecked coast for a day.
okay. Lockhart Gorge.
Yep.
Yeah.
And explored just kind of around Melbourne in general. The botanical gardens were incredible.
The zoo's not bad either.
Yeah, I went up to the sanctuary up there. Is the
Oh, okay.
Healy Sanctuary?
I've not been there. I haven't been to Melbourne that many times. But for what if you're going back to Australia, that's the way to fly in. Don't fly into Sydney. Fly into Melbourne.
Yeah, I flew indirectly to Melbourne. Flying out was exciting because that's when I decided to come down with a pretty terrible cold. So that was a lot of fun for that day of travel. Of course, and time zones are always fun when you leave at 9 a.m. Saturday and you're on the plane for 16 hours and you arrive at 7 a.m. on Saturday.
Before you left, yeah.
And you just get to start your day over. That was a lot of fun.
So Chris brings up a great point. When you have the opportunity and you're traveling for work, pair it up with some vacation days and explore a bit. Even if you're in grad school, for those of you pursuing that route, you go to conferences that require some traveling, always take a couple vacation days. Okay. Well, if there are no other questions, stop me if there are. I will wrap this up. Thank you so much, Chris. Give you a bit of a round of applause here.
I hear a couple.
We will definitely have to have you come back in person and tour our lovely campus again. See all the updates, especially with our new science building in a few years. Everybody stay tuned. Next week, we have 2 more alumni from our program. Brian Musin and Claire Everson are both alumni of our program. They're working at Hydrite. So thank you again, Chris. And we'll see you all next week.
It's been a pleasure. Thanks, everyone.